Alright, so here's our second example. We have to solve the equation root 4x plus 5 minus root 2x plus 2 equals 1. Now it turns out that when you have two roots being added or subtracted, the equation it becomes a lot more complicated to solve. Right? It's still the same basic procedure, but you run into the problem of having to square both sides twice. Right? So let's just go through our steps 1, 2, 3, 4 like the other examples and try to keep it as simple as possible. All right, so step 1 is always to isolate one of the square roots. So I'm going to choose to isolate square root of 4x plus 5, which means I have to bring this other quantity to the other side. So I'm going to add root 2x plus 2 to both sides. Okay, this is going to have the effect of getting rid of the square root 2x plus 2 on this side and isolating the root 4x plus 5. So let me write what we're left. So I have the square root of 4x plus 5 equals 1 plus the square root of 2x plus 2. So I've isolated the radical on the left side. So the next step says I have to get rid of the radical by squaring both sides since it's a square root. So let me go ahead and square both sides. So when we square both sides, the radical, the square root on the left side of the equation is going to cancel with the squaring operation. So the left side of the equation simplifies to just whatever was underneath the radical. So 4x plus 5. Now on the right side of the equation, we have a little bit more work to do. Okay, we have a plus sign. We have a binomial, okay, a two-term polynomial being squared. In order to square a binomial, you have to FOIL. So we have a little sub-problem that we're going to work out over here, where we FOIL 1 plus root 2x plus 2 times itself. Okay, so let me work out the steps for this quickly. Okay, so here's the results of our foiling problem. Okay, when you take 1 plus root 2x plus 2 times 1 plus root 2x plus 2, you have to FOIL it out. So this 1 needs to get multiplied by this 1, which I wrote right here. This 1 also needs to get multiplied by this root 2x plus 2, which I wrote right here. Then this whole root 2x plus 2 needs to get multiplied by 1, which I wrote right here. And then this whole root 2x plus 2 also needs to get multiplied by this root 2x plus 2. Now this is a little tricky. When you take root 2x plus 2 times root 2x plus 2, you're multiplying a square root by itself, so you're squaring a square root. This square and this square root end up leaving you with just what was underneath the square root. They end up undoing each other. Okay. So then I simplified what I could. The square and the square root canceled, like I said. But then here I have 1 root 2x plus 2 and another 1 root 2x plus 2. Those are going to combine, right? 1 root 2x plus 2 plus another 1 root 2x plus 2 gives me 2 root 2x plus 2. And then 1 times 1 is still 1. Finally, we collect like terms. So this 1 and this 2 collect to this 3 here. Okay. The 2x comes down. And the 2 root 2x plus 2 comes down as well. So after FOILing out 1 plus root 2x plus 2 times itself, you end up with the expression 3 plus 2x plus 2 root 2x plus 2. So that's what I put in here. 3 plus 2x plus 2 root 2x plus 2. Okay. As you can see, after doing this huge foiling problem and simplifying the right side the best we could, we still have a square root left. Okay, we only got rid of one of our square roots by squaring both sides, which means we have to again isolate the square root and square both sides one more time. So let's do it. If we want to isolate the square root on the right here, we have to subtract 3, subtract 2x, right? Bring everything else to the left. Subtract 3, subtract 2x. Right, so that's going to leave us with 2x plus 2 equals, these are gone, right? 0, 0. But I still have 2 square root of 2x plus 2. Next, because I have this 2 connected to the square root by multiplication, I would get rid of it by dividing both sides by 2. So let me divide by 2. If I divide this side by 2, I have to divide both terms by 2. Okay. So this reduces nicely. 2 over 2 is 1. Again, 2 over 2 is 1. And once again, 2 over 2 is 1. So let me write what I have left. 1x plus 1 equals 1 times root 2x plus 2. So really just root 2x plus 2. So now, now I kind of have to clean up my workspace here because I have too much garbage. So let me go ahead and clean this up so I have more room to start dealing with this new equation. Okay, so that's a little better. I can breathe again at least. Remember, what did we do so far? We moved the square root over so we can isolate root 4x plus 5. We squared both sides to get rid of the root on the 4x plus 5. When we did that, we had to FOIL. There was a big mess. But after we simplified everything, it ended up looking like x plus 1 equals root 2x plus 2. Now we're going to have to once again square both sides to get rid of this square root. So I'm going to write square and square. On the right side, it's a pretty straightforward calculation. The square and the square root cancel each other out, and they leave you with what was underneath, which is 2x plus 2. On the left side, because of the plus sign, you know that it's another foiling problem. You have a binomial squared. So you're going to have to calculate what x plus 1 times x plus 1 is. Okay, but this is a little more straightforward. X plus 1 times x plus 1, if you FOIL it out, is x squared plus x plus x plus 1. And if you collect like terms, this becomes x squared plus 2x plus 1. Okay, and we still have this equals 2x plus 2. All right. So now we got rid of the radical, both of them, all of them. All right. And we're looking at a quadratic equation since it has an x squared. So our next step in the procedure is to go ahead and try to solve this resulting quadratic equation. So let me go ahead and move up here so I can get some more room again. So I need to solve x squared plus 2x plus 1 equals 2x plus 2, which is a quadratic equation like we said. So we're going to get one side to 0 and then either factor or apply the quadratic formula, or even complete the square if we want. So what happens when I move everything to the left side? Well, these are going to go away. I'm going to be left with 0 on the right. And then over here, I have x squared 2x minus 2x is 0, so it's gone. And then 1 minus 2 is negative 1. X squared minus 1 equals 0. This is actually very easy to factor, right? It's a difference of squares. So I can solve this quadratic equation pretty quickly by factoring this down into x plus 1, x minus 1, which has to equal 0, and then setting each factor to 0. X plus 1 equals 0, or x minus 1 equals 0. Right? This is the factor method of solving quadratic equations. Alright, so finally we have to isolate x by subtracting 1 from both sides on this first equation, which gives us x equals negative 1. On the second equation we add 1 to both sides, which leaves us with x equals positive 1. These are our proposed solutions. These are what we think solves this radical equation, but we have to be sure. Right? We have to perform our fourth step of the procedure, which is to check all the proposed solutions. So let's go back and plug both negative 1 and positive 1 into the original equation and see if they satisfy it. So plugging negative 1 and 1 back into the original equation, we get these expressions. When you put in negative 1, you'll get the square root of 4 times negative 1 plus 5 minus the square root of 2 times negative 1 plus 2, and that's supposed to equal 1. Simplifying, this is negative 4 plus 5, which is 1, so we have square root of 1 here, minus negative 2 plus 2 leaves us with 0. Square root of 1 is 1, minus square root of 0, which is 0. 1 minus 0 is 1. This checks. The solution's good. So x equals negative 1 is a valid solution. We box it. X equals 1 actually is also a valid solution, and you go through similar steps. You plug in 1 everywhere you see x in the original equation. It ends up giving you square root of 4 plus 5, which is square root of 9, minus square root of 2 plus 2, which is square root of 4. This is square root of 9 is 3, minus square root of 4 is 2, 3 minus 2 is 1. This checks out. Okay, so both of our solutions ended up working. So we circle them both, and that's it. Finally, we've slayed this beast of a problem.